So welcome everybody. We will get this webinar started. So welcome to this webinar on chemical risk management. Such a huge topic, as Bill has already alluded to. It is impossible to cover everything in 45 minutes. So hopefully you know the drill with these webinars. It's a 45-minute webinar, but we do have time in here for questions because the webinar is for you. It's not for Bill or I. We kind of know this subject. Well, Bill knows it more than I, but it's not for us, it's for you. So any questions you have, if we can't address them today, we will try our best. We'll take a note down of your information and we will contact you and try and help you. So thank you so much for attending and for sparing your time to come and join us with this webinar. It is being recorded, so we're not going to mention any names. If I do, apologies. Hopefully I won't. Bill's going to be watching me. But we do recognise some familiar names on the webinar. Welcome back. So this is the first of 5 webinars that we will be doing this year. It is in the chat from earlier, but let me just make sure it's in there again. There are a number of other webinars coming up this year, so make sure you keep an eye out for them on the ICW website. And a huge thanks to ICW for putting on this webinar. So I explain very briefly on the next slide who I am and also who Bill is and who ICW is. So we'll cover that very, very quickly. Hopefully, you know the drill by now. Please participate. The chat function works. You should all be muted anyway. If for some reason you're not, then please make sure you are. All of these webinars will be recorded so you can come back and watch them. Or if you have some colleagues that you'd like them to watch them, then within the next 24 to 48 hours, you should get access to the recording of this webinar. Any questions you have, the email is there. So e/marketing@icw.io. That didn't come out properly. And also it's a dash, right? Not /. So apologies. It's there on the slide. Contact ICW if you have any queries. Okay. So a bit about myself. I'm a product safety consultant. If you've been to these webinars before, you probably know who I am. So I'm just going to very briefly say that I'm Geraldine Kosh. I've been working in product safety for 20 years. I've had the absolute honour and privilege of working with the amazing ICW team for a while now. I've done lots of different training sessions on lots of different topics. I've worked on injury data collection, worked on a few British standards that are noted there, and also worked on some projects that are sponsored by the European Commission and are known as SPEAK and the CAST projects, which are really great projects in preventing injuries and ensuring that consumers are protected, which I know is something we all want to do. So that's enough about me. Let's find out about Bill.
Hi, I'm Bill Baxter, and I only have 10 years in the TIC industry, but that was preceded by 10 years as a designer and product developer. So 20 years of consumer product experience, and then 10 years dealing specifically with chemical and restricted substance lists, primarily for test labs. And currently what I'm doing is helping mid-sized companies manage their compliance and chemical requirements. So it is a more general approach to make things easier for small companies that may not have a dedicated compliance person or may have an understaffed compliance department that just needs a little bit of help. And spend a little time doing standardization work as well.
Amazing. Thanks, Bill. Okay, so we'll quickly talk to you about ICW and who ICW are. I'm sure you all know by now, unless this is your first webinar that you've attended from ICW. There's a number of historical webinars that are on the website as well that I constantly refer to because they cover some really great topics, as well as this one today. But ICW fundamentally has a team, an amazing team of approximately 60 people that can support you with your compliance needs. And one of the main tools that they have is a software solution that can help you with the administration of compliance, which can be really tricky. I think it's one of the biggest headaches in compliance is the administration, chasing up test reports, getting test quotes, inspections, all of those things. And ICW really support you with that with their system. So if you have any questions about what these systems look like, how they work, what the pricing is, then feel free to contact myself or any one of the ICW team and we can let you know more about that. Okay, so over to you, Bill, to talk about chemicals.
Oh no, we're going to swing right back to you for a little bit because
are we?
Our first topic is risk management.
That's my favorite. This is my favorite topic. Wow. Okay. So risk management. This is an interesting one, actually, risk management and risk assessment. And I think there's some key definitions that you have here, which are really, really important. And one thing I actually want to talk about is the difference between risk assessment and risk management. People often feel that when they have a certain risk level assigned to a product, so it comes out, it says low, medium, or high, then there's a magic equation on what they need to do in terms of risk management, but there isn't. And I think that chemicals, one way of dealing with chemicals, probably the key way of dealing with chemicals and product safety in general, is based on risk. Everything is fundamentally based on risk. So it's really, really important to understand what these terms mean, and we'll mention them very, very quickly. So harm is the adverse impact, which can include human injury, ill health, damage to property, damage to the environment, and economic loss. And hazard is the potential source of harm, so where that actually comes from. And then when you're looking at risk, you look at the likelihood, so the probability that event will occur. So we are surrounded by hazards every day. I'm sure Bill is where he's sitting, and I certainly am. Everywhere in my office, there's hazards. But when we're looking at risk, it's looking at the likelihood of that actually to present itself and how it can lead to injury. And with chemicals, there's a number of different ways that that can happen. And we will speak about that.
All right. And so that gets to the basic risk equation, which is that it's the severity of a hazard or the potential harm times the likelihood that that's going to happen. And so as a big picture, this means you can reduce the hazard, design the hazard out of a product, but sometimes we can't do that. And in those cases where we can't, what we want to do is keep either changing the design or adding preventive measures or potentially adding warnings that reduce the chances that the hazard will actually injure someone. And then the other function of likelihood that is usually thrown out in consumer products is just the number of units on the market or the number of users. And when we get to chemicals, there is a couple more definitions I want to hit on so we can talk about why chemicals are regulated the way they are and hopefully get to some concrete help in thinking about the risk in your products and how to reduce it. So these are three terms that are hugely important when talking with chemicals, because if you think about any consumer product in the world, it is made of chemicals, all of them. And so typically when we're talking about chemical regulation, we need to distinguish between something like a plate or a Frisbee or a garbage can lid. And I need you to help me here, Geraldine. I can only think of circular things. Versus
put it in the chat if you can think of some other things.
but physical objects. And so typically those are articles. But along with articles, we need to separate that idea of the manufactured item, which is formed in a specific shape or design. It is any product where the shape of the thing is more important than its chemical composition. A substance, on the other hand, is a chemical that can be distinguished from other chemicals. So it needs to be molecularly different, but then within, I'm going too deep in the weeds. For our purposes here, we're going to deal with a substance primarily as a liquid, paste, putty, or gel. A substance is something that is primarily chemical in function, and the shape matters less. Doesn't mean it doesn't have a shape. So you could have something like soap would be an example of a substance where the shape matters because you need to be able to rub it on your skin. Lip balm, another example where shape matters, but really it's about the chemicals in the cosmetic. And then finally, and then I'm also going to, as we are talking, I might interchangeably use substance to mean the chemicals that we are looking for in the material in an article. So if we're talking about lead or phthalates or PFAS, we might refer to those as substances, because that is the idea where it is a chemical that is different from the material around it. It is chemically unique and but it's still just the general category that includes the elements, compounds, mixtures, whatever. And then finally, I want to talk about polymers because polymers hit an unusual place in chemical regulation because they sort of sit on the line between substance and article. So for most purposes, they get treated as a substance. So essentially you have, when you have a polymer, you have a little link in a chain that is called the monomer. And then you are making molecules by going bloop, 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 and creating much larger molecules, eventually to the point where it behaves like a solid in many cases, or an extremely squishy solid. But really, if you were able to look at it down on the molecular level, what you would be seeing is a giant mass of spaghetti, of long chains where the ends of the spaghetti might be connected more like a net, but there's space in between these polymer structures. All right, so the other things that I want, a few more things to talk about that are specific to chemical risk management is, so there is the total content. When we are doing testing in consumer products, the total content is the total amount of a substance in some kind of substrate or matrix, which is different from the amount of that substance that gets out of the substrate or matrix into the body. So we call that the exposure. It is possible to have a fairly toxic substance, but because it's locked up in the molecules in the material, it isn't getting out of the material and exposing the user to a hazard. And then finally, I want to talk about exposure pathways. This is where we're getting out of the sort of classic lab approach to chemicals and into a more toxicological approach, where the exposure is traveling perhaps from the material into food that you're then eating. So it could be that the material in a consumer product is got any of the hazardous chemicals locked up inside it when you go to touch it. But once you've put hot food in it, the hot food breaks down the molecules just enough that it allows some of the harmful chemicals to leach out into the food, which then we eat, setting up a potential toxicity situation. So I guess at this point, I want to check and see if there are any chemicals or anything anyone wants to add to some of these sort of basic terms that we're going to need to talk about risk and likelihood.
No one's come in, but I'm thinking, which is dangerous. But sometimes with clients, they'll be like, oh, we've got, do you call it MSDS or an SDS sheet? And, is that enough? Is that okay? And for me, then what I think about, and you'll correct me if I'm wrong now, but that doesn't really tell you about the risk, which is when we're looking at like a TRA, which is a toxicological risk assessment, because exactly what you're saying, there can be a chemical that's dangerous, but we need to look at what's the risk of that. A bit like when I'm sitting here in my office, I'm surrounded by things, but the TRA will put in perspective of how it can actually injure you, right? And just some other key terms I'm thinking to cover.
Yeah, those
perfect.
Totally aren't part of the last section or anything. Okay.
Oh, I know. I'm preparing for it, right? Yeah.
Yes. So yeah, those are the SDS is a sort of general guide to how to deal with a substance as a hazardous substance. Do you need to take special precautions?
Yeah.
Do you need to be prepared for particular hazards, like it's going to catch on fire when you open the container,
Yeah.
and how to put out that fire when it does it? But the risk assessment is much more suited to chemical products. And really, in the US, um, the legislation that deals with chemical hazards assumes that you understand the sort of information you get from a TRA. So it is possibly the single most important document you can get for your particular substance
Mm.
when dealing with US chemical regulations.
Right.
All right, so let's move on to the first section is going to talk a little bit about the hazards of chemicals. So approximately 30, 40 years ago, there was a big shift in the way we started thinking about chemicals and the hazards related to chemicals. The classical mode, the sort of toxicology mode, is that the main danger of chemicals are acute health hazards. So with these, we're talking about the toxicity. So that is just straight up, is this poisonous? If you drink it, how much of it do you have to drink before an organism dies? And then the next obvious one are corrosives, irritants. These are things like some cleaning solutions, formaldehyde. This is the hazard where your skin essentially gets damaged on the skin level, creating rashes and eventually blisters. And potentially, depending on exactly what the chemical is, it could even dissolve the skin. The next sort of classical hazard is the flammability of the product. And I tend to think of with that, if the chemical is kept in a pressurized container. Because typically whatever chemicals are being used for pressurization are typically pretty flammable. So an otherwise not flammable sunscreen could become flammable because a pressurization agent that is flammable is in there with the sunscreen. And then these are the sort of new ways of looking at chemicals that started really coming into the heads of regulators and toxicologists as we got into the 1980s and even more so in the 2000s. And that's thinking in terms of chronic hazards. So up until that point, we had been really thinking in terms of when you're using this product, is it poisonous immediately? What became more evident throughout the 70s and early 80s is that chemicals presented hazards that built up over time. So that, for example, lead in gasoline was, when it was burned, creating a tiny film of lead on everything. Or lead in art products was creating long-term poisoning, just very slow acting. So from the views of classical toxicology, it wasn't acting fast enough to create an LD50 number, which is the scientific study of subjecting animals to the chemical and figuring out how much chemical it takes to make half of them die. It doesn't get used as much anymore, but it's still there in some of the laws around the world as the standard of how to determine toxicity, but that's not going to catch something like the reproductive harms that we're looking at these days. So between this kind of looking at chemicals in terms of their chronic hazards and looking at chemicals in terms of, this is best illustrated by the PFAS or by phthalates, where the suspected harms of both of those chemicals are a little bit unclear on the individual product or individual person level. What is clear is that at high levels, the chemicals seem to be harmful. And the chemicals seem to collect in our bodies and definitely collect in the environment. And so a lot of the more modern approaches to chemical regulation is focused really more on these last 2 points. As that kind of persistent, so then the next hazard that tends to get dealt with are the environmental hazards. And really, when you look at environmental hazards, it's taking those health hazards, but pointing out that these chemicals do collect in the environment, and then they harm the animals, plants, and eventually humans that are living on this planet. And because the planet in the end is kind of a closed system, a little bit isn't a problem, but as it builds up and builds up, there are knock-on effects, and maybe it throws the environment out of whack. And so some of the laws are focused not so much on hazards to human health, but hazards where we see fish die-offs, or we see other smaller animals getting affected by our chemicals. And this is of particular concern in the EU. In the US, it varies a lot by where you are in the US, how much the regulatory and enforcement bodies are interested or concerned or looking to prevent sales based on environmental hazards. Which leads us to, as makers of consumer products, we are also concerned that there are hazards to our business that are based on the regulations in different jurisdictions, the enforcement based on the chemicals in our products. How are they likely to be found? What is the hazard to our customers versus just the inability to sell? These are all things that we have to be looking at when we're making our risk assessments. And we might take different approaches depending on the regulatory environment we're selling into, even if the potential hazards to health or environment are identical. So, the best case example would be if we really don't believe there is a hazard in the product, but we're still going to follow the rules of the markets that we're selling in, just to make sure that we are producing something compliant and protecting ourselves from enforcement that isn't needed. And then finally, this one is relatively new. We also have reputational hazards, which are a lot like regulatory and enforcement hazards. And in the US, frequently stronger than regulatory and enforcement hazards. And so there are non-governmental organizations, many of them are looking to find people who are producing chemical products and looking to shame them into stopping. So at some level, organizations like those that are represented by the Safer States website are looking to increase regulation as part of their mandate, but they're also looking to get news reports out there about companies that are presenting chemical hazards to the environment, and in some cases, companies that are creating hazards for children, and they're focusing on the chemical effects as one of the hazards they're trying to control. Right, so do we have anything coming in from there?
No, no questions. I have a few, but I can save them to the end.
Okay. Actually, there was a note that I have here from the last time we went through this.
Yeah.
Did you want to ask anything about what the risk of chemicals are in the EU?
Yeah, I was gonna save it to the end, but we can do
Oh,
that
okay.
now. That's yeah. I think I did think of that when you were mentioning this, and it made me think of like Prop 65 and Reach, because I was thinking, and I don't know if it's correct, like, but we have Reach right here that is covers a lot. Whereas when I think of the US, I think of state legislation. I think of Prop 65, which is very state. I mean, yeah. What are your thoughts on that?
So the US, one of the things that is sort of different about the US and the EU is that the US got to regulating chemicals first. So they started regulating chemicals all the way back in the 50s in food contact items, not in consumer products so much, other than the really, really toxic sorts of chemicals. So you have the Hazardous Substances Act, and you have the Food, Cosmetic, and Drug Act. And so the people who were making rules in the 50s kind of set up the framework in the US. And over the course of the 20 to 30 years that followed, you were on this sort of classical toxicology model. And then around the late 70s, early 80s, there is a constituency of people in the US that are seeing these additional chronic health hazards. And so they start working to try and create more rules at the federal level, but it turns out to be incredibly hard. So that gets shifted into a fairly large constituency of chemical companies and product manufacturers that don't really want change, and another large constituency of people outside of those groups that do want change. So often they're medical, often they're non-governmental organizations, or people who've been negatively impacted by those chemicals. And so in the US, we end up with this strange patchwork where the people who are trying to make change are just trying to make it wherever they can. And so that's led to sort of one fairly robust federal system for the really, really hazardous chemicals, and then a patchwork of individual states, including Prop 65, that are the laws that affect your more long-term and persistent chemicals. So in that window of the 80s is essentially, and I'm oversimplifying a lot, and when the EU got together. And because the EU was already trying to organize 20 some odd different constituencies into one framework, the only sensible thing to do was to come together and agree on that framework and have an organized framework from the beginning. And they had the mess that the US had already created to look at and work from as they were developing REACH. Because REACH very nicely takes three or four, well, at least two different agencies from the US and three or four different laws and combines them all into one organized framework that, what is it, 28 countries can agree on? And so that is sort of the real difference, is that you're looking at a piecemeal mess in the US and you're looking at a more organized system of rules, if not enforcement, in the EU. All right. So I'm going to jump into the next section where we talk about dealing with likelihood, because it isn't always about the number of customers. So there are general, and these are very general techniques that we can use to reduce the likelihood of harm from chemical products. First of all, we can restrict the users of the products. So those really toxic chemicals tend to be restricted to situations where only professionals are using them, or only adults that understand the risks of using a pesticide or using a high-end chemical are allowed to use the products. A child wouldn't be expected to use a pesticide. A child wouldn't be, it's normally warned against using a drain cleaner. And then another way that we reduce the likelihood of harm, this is reducing the potential paths of exposure, is to require protective equipment when the chemical is used. Again, this is very common in your industrial kinds of chemicals. It is far less common in consumer products because we're really looking at a situation where we can't control whether protective equipment is going to be used, and we can't control if an at-home consumer has protective equipment. So the next two are the two paths that get used most often in regulations. The first is to limit the migratable content. So this is either using, this is a good example in the toy regulations in the US and in Europe. They use EN 71 in Europe, and in the US, the heavy metal soluble and total lead content, to simply test the product and see whether or not a short list of hazardous chemicals will come out into hydrochloric acid, which is intended to simulate stomach acid. In the US, they've taken it a step further with the idea that if we limit the total amount of lead that's in a substrate, well then, no more than that can possibly come out. It makes the two markets a little bit out of sync, but not very much. I mean, in the end, the goal is to get down to as close to zero with all of these chemicals. And then what has happened in the US state laws is that a lot of them have just, they don't want to set limits. They don't want to say that some use of this chemical makes sense, or that some amount of this chemical is worth the risk. And so those laws are set up to ban the use of particular chemicals or classes of chemicals in products, frequently intentionally. So this is a case of something like PFAS or flame retardant rules. Those are set up to just say these chemicals cannot be used in our state in products. And when we are dealing with the different states, the only real path we have is, when you're dealing with the law, it's the law. The simplest way to reduce your regulatory risk is to comply with the required testing, and whenever possible, communicate the requirements down your supply chain, because we can't stop chemicals at the end of the process. We can only stop them at the beginning. So before we get into looking at other kinds of risks and ways we can try to reduce exposure, reduce likelihood, it's important that we always have to follow the laws, even when the law may not make sense in a particular case, because that is the basis of what lets us do business globally. All right, so I am going to throw out now some random risk management concepts, ideas, tips, because we're not looking at particular product types and we're not dealing with particular sets of regulations or even particular hazards, it's going to be very general. And so we would really welcome questions about specific situations, specific product types. But we need to be very clear that one of the great risks of chemicals is that it's really hard to tell if they're in your product. And so that is why there is so much reliance on testing. But maybe if you get to know what materials are in your product, what chemicals are in your product, then that'll help you make decisions on managing the risk of those chemicals much earlier on so you can prevent them from getting in the first place. So these are the highest risk product types. These are the types of products that tend to have chemical hazards associated with them, not always for the same reasons. So the first two, chemical products and cosmetics, are sort of obvious because they fit into that substance situation where they are liquids, pastes, putties, and gels, and we are changing the formulations of them and creating new formulations that never existed so that we can get them to behave differently and do more of what we want. And the main way we do that is changing the chemicals that are in each product. So these are two categories that are actually fairly heavily regulated and have a fairly robust industry standard about chemical safety. But they are currently being targeted for some of the chronic and persistent chemicals that are coming up that aren't covered by the existing more toxicology-based chemical requirements. Food contact products, particularly in Europe, are heavily regulated, and they are regulated based on being articles that are being treated as substances. So the idea is that even though typically you wouldn't expect chemicals to come out of the product, because it is right on that exposure pathway of you're eating off of it or potentially a hand-to-mouth exposure pathway, food contact products get a lot of regulatory scrutiny. And frankly, they deserve it because what is happening is that we need to make sure that we can all trust going into a store and buying a plate. That plate is not going to inadvertently poison me. Art supplies. Go
Sorry,
ahead.
Bill, very quickly, we have a question come in, and also we've
Sure.
only got 5 minutes left to try and get through the slides. But I don't know if you're going to be able to answer this now. We can get back to the person if you can't. But the question is, so how should one approach unavoidable residual precursor side products, for example, styrene monomer in polystyrene? Sounds very technical. Do you think you have anything to add on that, or?
So it depends on where you are in the supply chain, because really that's only going to be able to be addressed by the supplier of your polymer. If you are sort of at the upper levels, your primary tool is going to have to be either setting up your relationship with the supplier so that they're required to meet certain regulations, certain levels of monomer and test for them. This is more a matter of, because that's a potential risk, it needs to be something that is a red flag that you're dealing with up front. And perhaps it's going to require setting up a testing regimen on the raw materials to make sure the monomers not at unacceptable levels in the incoming material. and then comparing that to the material that comes out of your manufacturing process.
Yeah, that's great. And I think that's very relevant for all products and chemicals, right? It depends where you are, and then it's a risk management strategy and working with your suppliers. But yeah, we only have 5 minutes left, but do ask any other questions, and hopefully we can whiz through the rest. Thanks, Bill.
Okay. Art supplies, your toxicological risk assessment is going to be very important there, because this is another case of formulation that is slightly less regulated than the cosmetics or chemical products. In the EU, that all falls into the same bucket. In the US, those are considered different buckets. And the art supplies get a special chronic health hazard requirement in the US that we call LAMA.
LAMA, yeah.
Upholstered furniture is high risk because flame retardants, and there is both a belief in the furniture industry that upholstered furniture can't pass flammability standards without flame retardants, and a tendency to use flame retardants in the soft foams that are typically used in upholstered furniture, but also get used in other products, because it is possible to find chemicals that will simultaneously act as a flame retardant and as a plasticizer. So it makes it both squishy and more resistant to catching on fire. And your foam manufacturers might lean towards that sort of as their basic standard, so that they can check both boxes with one product. In a similar vein, these are the highest risk materials. These are the things that you need to be looking at when you are trying to assess where your regulatory and actual health risks are. And the top three are all plastics. PVC is well known because both lead and phthalates have useful functions in it. And TPE and TPR, I like to think of as a plastic soup. So the formulations vary a great deal, and almost any chemical can end up in your TPE and TPR. So you want to be very careful sourcing those up front, particularly when you're using them in food contact applications. I just mentioned the foamed plastic and foamed rubber. Those tend to carry foaming agents, which could be formamides, could be PFASs, and flame retardants. So always take extra care with your foamed plastic and foamed rubber. Man-made wood, because of the adhesives that are used in making the man-made wood, they tend to contain formaldehyde and potentially, although less often, BPA. Waterproof and stain-proof materials or coatings are a big risk for PFAS. They're likely to contain formaldehydes. And PFASs are, you don't always recognize when being waterproof is important, and so it's been coated. So for example, if you have any textiles on your electronics, you want to double check and know whether or not PFAS is being used on those textiles to help protect the electronics from water damage. It is a very common approach. Leather, which is known for breaking down into chromium and creating chromium-6 over time based on the tanning processes. So it's one that you need to be able, the risk you want to be looking at is, can you check further upstream on your supply chain and make sure that your shipping methods aren't doing anything to break down the chemicals that were used to tan it. And then finally, powder coating on metals, which is usually seen as fairly inert. Part of the process of putting it on involves both BPA and PFAS. And it should be double checked if you are in a situation where you need to be watching out for either of those chemicals, like on a food contact item or on a children's product where they're more heavily regulated, even if the particular sort of mode of exposure is fairly unlikely for powder coating. People, tends to be on large metal objects that people don't tend to touch. And we're almost there. We're at the very end. And this is, these are the main risk reduction strategies. And the most important one is communication with your suppliers, letting them know that you're looking for particular chemicals, letting them know that you think they might be in particular products, having them test their raw materials before they go into productions or as part of them qualifying the raw materials they're going to use. Looking at their quality control plans, making sure that they have some sort of chemical control, or when you're doing a factory tour, are the chemicals and polymers being kept segregated? Are they well labeled? Is there something that shows this chemical, some sort of log that shows when chemicals are being used for particular products? Restricted substances lists tend to get used. They're kind of a broad brush and not great for all products, but they work very well in the textile industry, where you can just have a large list, give it to your supplier and say, these chemicals are not in my product. I don't want them in any of my products, and we're going to check randomly. Supplier audits. There are several companies that offer chemical management audits and and policy reviews. That could be a tool if you can't communicate as well with your supplier for some reason. And then the use of certified raw materials like your Oikotex or your Bluesign. Some chemicals are being, repeatedly tested to make sure that they are not using any of the harsher chemicals, and there is definitely a market for products that are using these kinds of certified materials from creation point to final production. Then there's the typical raw material and component part testing. This is the hammer of chemical compliance. And then the scalpel of chemical compliance are really these last two, and that is the toxicological risk assessment, where you look at the amount of chemical in your liquid or gel or chemically based product. And then you look at the specific use, who's going to be using, how much is in the package. If there's a worst case where a child drinks the whole package of it, what's the result? Is there any required toxicological labeling for your product? This is the most important thing you can use to ensure that a chemical-based product is safe. And that includes cosmetics, art supplies, things that are typically thought of as more standard products. And then safety data sheets, which have become sort of the currency for what chemicals are in these products. In the EU, these tend to be passed around as part of REACH compliance. They are not always the most useful for talking about the particular product, because a safety data sheet only addresses the hazards on a chemical level and doesn't usually address exposure in the particular final product. So
I think we're just overrunning there by a couple of minutes, but yeah, it's great. Very useful slide. Okay.
All right.
So I think the next one is okay.
Oh,
so
the next one is just, if you have additional questions, feel free to reach out to me. And then
amazing. Yeah, and thank you so much. Sorry that we overrun there by a couple of minutes, and hopefully when you leave, before you leave, you will get a feedback form, but I'm just going to put that in the chat, and if you can complete that feedback form, that would be great. And Bill, thank you so much. It was difficult to do in 45 minutes, right? Because it's such a huge topic, but you did a great job.
Well, unfortunately, it's
Thank
easy
you
to go
so
off on tangents too. So
That's okay. That's okay. Well, thank you so much, Bill. And thank you everyone for attending. We really appreciate it. Have a wonderful day or evening wherever you are. Thank you. People are saying thank you. Thanks so much. Bye.
thank you all. Bye.